Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh to Madam Zaifila. So my name is Nimza Iskandar bin Hafizur Rahim, and for the assignment 2 about geometry, at first I will explain the definition of geometry. So what is the geometry? Geometry is a branch of mathematics focused on studying the properties, measurements, and special relationships of points, lines, angles, and surface. So at this point, derived from the ancient Greek words meaning earth measurement, geometry provides the logical framework necessary to describe physical structures. So it is broadly split into the two areas: plane geometry, which handles two-dimensional shapes like triangles, quadrilaterals, and circles on a flat surface, and solid geometry, which address three-dimensional objects like cubes, spheres, and cylinders. So geometry forms the bedrock for advanced fields such as physics, navigation, architecture, and engineering. Alright, so and after that I will explain about the characteristics of basic geometry formulas. So at first, basic geometry formulas are algebraic shorthand expression used to determine the special quantities of different shapes such as perimeter, area, and volume. These formulas possess distinct characteristics that make them globally uniform. So for the first characteristic that I want to explain is the dimension-specific outputs. So the structure of the formula dictates the dimension of the result. Linear formulas measure boundaries in one-dimensional units. Area formulas calculate surface coverage in two-dimensional square units. And volume formulas compute internal space in three-dimensional cubic units. Alright, so for the second, reliance on specific variables. So formulas use predefined variables corresponding to physical measurement. And common variables include radius, diameter, base, height, and width. So that was an explanation for reliance on specific variables, right? So for the third characteristics of basic geometry formulas is integration of constants. At this point, many geometric formulas depend on unchangeable mathematical constants. So, for instance, any calculations involving circles relies on the constant p, while calculating the area of triangle always requires the constant factor. So, the fourth characteristic that I can give is universal invariance. So, geometric formulas are universally true, and the formula for a shape remains exactly the same regardless of the shape's size, its rotation, or its position anywhere in the universe. So, for the third questions that Madam have told that how to design a yacht with the trigonometry, right? So I just wanted to explain how the people design the yacht with the trigonometry formula. So application of trigonometry in yacht design. So in naval architecture, a sailor designing a yacht must use trigonometry to balance the invisible forces of wind and water, ensuring the vessel is both fast and structurally safe. Alright, so for the first thing of the design for the yacht, they need to make orientation of the sail. So for the orientation of the sail, a yacht sails work like an airplane wing, generating aerodynamic lift when wind flows across it. This total wind force acts like an angle and must be split into two parts. So we have a forward thrust and a sideways leeway. So by using the sine and cosine functions of the apparent wind angle, the designer can calculate the exact angles to set the sail boom. So it's maximizing the forward force vector, ensures the boat moves forward with maximum efficiency. Alright, so for the second trigonometry things that can be built for the yacht is the deck design. So for the deck of the yacht serves as a structural shield and a platform for the crew. Structurally, the deck must support the massive downward compression force pushed by the heavy mast. So designers use right angle triangles to calculate the exact angles for structural support trusses under the deck, distributing the load safety across the hull. So yeah, trigonometry is also used to calculate the slight angle or slope across the deck beam. So at this point, this precise angle ensures that ocean water drains off quickly through side drains while remaining flat enough for the crew to walk on safely. So for the final trigonometry things to design the yacht is for the boat angle. So for the boat angle, we know that boat angle have a heel and keel balance. At this point, when wind hits the sails from the side, the yacht tilts or heels. So this yacht is to keep the boat from the flipping over. A heavy weight called a ballast keel hangs under the boat to pull it back down. As the yacht heels at an angle, the keel swings upward towards the water surface. So engineers use the sine function of this heel angle to calculate the length of the righting lever arm. So this calculation guarantees that as the boat tilts further, the gravity pulling down on the keel creates a strong enough. So yeah, it's built and create a strong enough turning force or torque to safely pull the yacht back upright. So there is my explanation about the definition of geometry, the characteristic of geometry basic formula, and also the trigonometry of the design of the yacht. So thanks for watching, madam. Have a nice day and thank you, and assalamualaikum warahmatullahi taala wabarakatuh.